I'm Justin Elliott, IT Manager, Developer here at Penn State. My colleague here,
Scott Gallagher, System Administrator here at Penn State. I do a lot in helping out with Justin and Rusty and them.
Yep. So, by a show of hands, who has already used Git?
One form or another.
Okay, great. All right. And question to ask him about level of experience. Who's got more than a years of experience with Git? Okay, great. Okay, good. Now, it's actually good that they have some experience too, because then if you're staying for the lab part, you'll be able to help out partners too on the lab machines as well. So that's great. All right, Scott's going to take over for the introduction, and we're going to switch a couple times. So
Yeah.
I'll pass it to you.
Our timer's not working.
What's that?
We don't have a timer.
Fine.
Yeah, we don't have a timer.
Oh, actually, it switches over. It'll kick in. It'll kick in after 2 minutes because in case the camera gets switched late. So that's fine.
Okay, so starting off, what exactly is Git and what are we using for? So in its basic form, Git is version control. And what does that actually mean? So with version control, we're actually able to control your obvious versions that you have with your software and with your code and stuff. So two of the things, so version control, VCSs will probably use it going forward, and source code management, SCM, pretty much the same thing like I said. So you're able to revert back to old code and stuff. So you're able to use that to management of, the changes of your documents, your scripts, pretty much anything text-based. I think you can use, Git or some type of version control for in that aspect. And we do have the link up there, so if you want a more, broadened term of revision control, you can visit the wiki link. It also provides the ability to check out source code in and out of a central repository, so you are able to run your own Git server if you want. Some of the people here on campus have their own Git server, but you can also use, resources such as GitHub and items like that. So why do you want to use it? So obviously, that's the reason why we're all here. So it will greatly enhance your ability to be agile and move quickly with developing scripts. And when I use the word scripts, obviously I mean anything that we can do text-related. So we're not just pinning that to scripts. It could be any type of code documentation, I think is real big that we've heard earlier in the week that people are using this for.
Switch configs and things like that.
Right. Yeah, and like I said, I think the biggest point, if you only take one thing out of it, I think is the second bullet point that we have. You can back out of mistakes easily. So, you make a change in something, you kick it out to everyone, you notice, oh crap, there's something I did wrong. You're able to pull back and go back in time. In that. So like I said, I think anyone that was at the boot camp on Tuesday, I kind of put it as far as like a time machine. So you're able to go back in time and see what you need to change or what can be changed at that point. It also is, removes the risk of updating your code. Like I said, so you can take those leaps and bounds and everything that you want. It's super easy to manage for different versions of your scripts and configs. So if you have, scripts and configs that you need this set to work with, a certain version of OS X and 10.6 or something, or even later, and then you need this set of scripts that does some stuff differently in 10.7 and 10.8. And I always kind of put for like version control and stuff. I do the Abbott and Costello routine, who's on first. So I think like during the whole routine, I don't remember which guy does which part of it, but one of them's super confused. He doesn't know exactly who's where, what's what anyone doesn't kind of get the flow of the whole joke and everything. So I think, that's more of the old school way that we're used to doing it. Shove things in folders, shove things in Dropbox, Google Drive. Whereas with version control, you have a better understanding of where everything is and, where all your scripts and files and text files like that are located. So keeping on with why we want to use it. So it's obviously very efficient use of tracking changes. Greatly enhances your documentation. I don't know if anyone's using it for documentation, but it is great for documentation. And it also enables and encourages collaboration, so you can work in teams on stuff and check things out and kick things back to your repositories. Some of the cool side effects helps to catch unintentional code changes. So if you make a mistake or anything, you're able to do that drawback and pull back. And easy testing on multiple machines, so you're able to do that, which I think is huge for anyone managing multiple systems. Why else? Liberates you to feel safe. Like I said, you can take those huge leaps because you can always go back, so you're not always, having to worry about going back and re-pushing things out. You just, can pull back your code and then recommit it if you want. You can always revert easily. It can be self-documented as well, and you can do code reviews on it. So what can I use it for? So like I said before, pretty much anything. Anything that is, text related. So we have, our documents, our bash, any type of scripts that you're using, server config stuff, and pretty much anything more. Binary stuff, it's not really, you can use it for that, but it's not really intended for that type of thing. So what else can you use it for? So ARD lists, if anyone's using the luggage as well, and if they're doing anything with iOS profiles and stuff, you can use it for that. So an example workflow of, what steps you're going to go through to actually do this type of setup. So obviously you're going to organize all your scripts into one repo or one location on your machine. You're going to edit all those scripts or create the scripts that you want to do. And then you're going to commit those to your repo, so that remote location. And then you can, check out your repo to make edits and items like that. And just remember, like through this whole session, whenever we say scripts, that's just our generic term for anything that could be text related. So when we say scripts, it could be documentation, and it could be anything like that. So up next, Justin's going to go over some more on Git.
Okay, so when we're talking about SCM, one of the best ones, the most popular ones today, of course, is Git. Everybody's been hearing about it at the conference with GitHub, SourceTree, Tower, lots of great GUI applications out there today. So Git is it is the newer breed of source code management tools. There are two basic kinds. There's one that was centrally hosted, a central versus a distributed model. Central is what I was using years ago with Subversion. I use Git now, and I've been on Git for about 1.5 years and haven't looked back. But the centralized was your Subversion repositories, where all of your code and scripts were. You had the most current version that you were working with, but you didn't have all the other previous versions on the same machine. Because whenever you needed one, you would check out from the server, download the data, get that difference, and then you'd be back there. So you had to go to the network, download it, and then you had that revision that you wanted to work with, if it was an older one. With Git, though, distributed means that you have the entire repo on your local machine, even if it's hosted on a server. Now, that means you're thinking, oh boy, that'd be a lot more space. But Git is extremely efficient with saving changes between commits and changes in files. So distributed, when I came from SVN, so by show of hands, who's used or is using Subversion right now? Okay. It's a little confusing moving from Subversion to Git, and you're thinking, why would I want to do this? But it was extremely liberating. Once I wrapped my head around it, it was a lot easier to work with the entire repo locally. Because it's distributed and where all of the files are local, Git knows of all the changes. If I want to, as long as my local repo is updated and matches the most current version of the remote, then I can revert locally, and it doesn't have to go to the network at all because I have all of the changes locally. With that said, I want to make sure people understand you do not need to have a remotely hosted Git repository. You can do it completely on your laptop and never use a server. You do not need a server for that. You can create it locally with either GitHub or SourceTree or at the command line by yourself, so you do not need a server. However, hosting, of course, is obviously a better way for collaboration and for backups when that server is backed up. So I want to make sure I clarify that. There are a lot of reasons, of course, Subversion. I won't go into the differences, but the distributed part was really huge. The .svn folder or directory and all of the folders, with Subversion, it was very difficult to move files around in the files and directories in the Finder. One of the benefits, huge benefits for me, is when I was using Subversion, I found myself avoiding moving things around because it's such a pain in the butt to do it, right? So if I went to the Finder and I accidentally moved something, there's the .svn folder in that directory, and you move it, SVN gets really ticked off. It says, I don't know what the heck this is. I'm going to re-download and recopy and have to restore. It's like, Git, when you do that in Git, it knows what that folder is. It says, oh, it's the same folder. And we'll show that also in the lab. It says, oh, you just moved it? Okay, cool. No data needed to be transferred. Just change it to my directory path. Good, we're done. It can be a gigantic directory, and it's instantaneous in Git. Subversion, not so much. So that was a really nice thing. It is easy to learn. Git can be at first daunting because you think, holy cow, there's all of these different things. And I look at it too and I thought, there's a lot of buttons in SourceTree. Why do I need all of these? Well, you don't need a lot of them. You can start with a very small subset and then expand from there. And that's what I did. And so GitHub is a really great application as well as SourceTree. So it's easy to learn. It can get complicated because it can do a lot of powerful things. You do not need to use those features. You'll hear about multiple branches and things like that. A lot of people are like, why would I want to? I love them. I use them a lot now, but it took me a while to get used to them and use them. And there's great documentation out there, and we'll talk about that. Yes, so here's the really cool part. So Git has excellent data integrity. And what this means is that it checks on everything. It knows what a file is based on the SHA-1 hash of that file. So if it's a really big file and you move it over, it knows it's the same file. So that's where it really excels. So I had a bunch of Subversion repositories, again, and they were a mess, and I never cleaned them up. I went over to Git, and I moved something actually by accident, and I noticed that when I was using SourceTree at the time, it says, oh, this moved, and I thought, wait a minute, the light bulb went off. I'm like, I can do this really quickly, and it was so fast, I thought, something's got to be broken in Git. It can't be that quick. It was. It knew exactly what it was. So, because it checksums everything, it knows if there's something has changed, or if something is new, untracked, and we'll talk about those things. So, if I sound like a fanboy for Git, it's because I am. Super fast performance, like I said, since it's all local and has all of the differences of each commit, it's saving just those differences in the file. So if you change one character in the file, it's not going to resave the whole another version of that file. It has a very advanced method of saying, oh, this is the same file, one character changed, I'm only going to change that one character, and that's it. Extremely efficient and very fast to restore to. I remember I had actually the MCP that's running, I had the version I wanted to back down to. And, well, this is back in the day also when I was doing larger repos for another thing I thought. I did a restore back to the previous version, and it was instantaneous. I thought, it can't have done that. And I go check, sure enough it did. So lightning fast. And easier branching than Subversion. I kept reading this before I actually jumped into Git about a year and a half ago, and I thought, yeah, okay, right. No, it really is. I was floored by how easy it is to do it. You can make it complicated if you want to, but you don't have to. You can start with just a master branch, which is one line of code, and continue editing that. Or you can go super geeky and use Git Flow, which is a really great design. The gentleman, name's escaping me now, if anybody knows the name. I'm all ears. But it's a great methodology for software engineering, hot fixes, and a whole bunch of different branches. And so it's a great way to go if you want to do more software engineering type things too. You don't have to branch at all, though. So there are basically three different classifications of Git file statuses. The first one is tracked. That means that Git knows what you've already committed the file, and it's now tracking changes to that file. If it's modified or moved, or which we'll think that actually is calling a rename. So if you rename files, it still knows it's the same file, just a different name. Very cool. So that's nice. Ignored. So this is the other cool thing about Git I really liked as well. Subversion. If you use Subversion, it's kind of a pain in the butt to configure to ignore files, right? You have to do different properties and do this, and it is not intuitive, okay? With Git, it has a .gitignore at the root of the directory that is your Git repo, right? You can have, that can be, you only need, if you want to ignore files, you need at least that one file, but you don't have to have any other git ignore files in any other directories, unless you want to. So, that file is a flat text file. It's extremely easy to edit. You can edit in the command line, the VI, or text edit, or VB edit, any of those. And you can do wildcards. So, for example, with the MCP program, for example, it has a lot of music to play, .m4as, right? 111 of them. I don't want those in the repo. They're big. And I'm not going to change them. You put them in, and that's it. So, you can, in git ignore, you can say splat.m4a, and it ignores all of them, and never sees them. So, that's kind of a nice feature. Untracked is talking about when you have added new files to a directory. If you haven't ignored them, it's going to show you definitely, hey, something's new, and it's not, I'm not tracking this, it's not in the repo yet, but this is a new file. It's got a question mark in a lot of the GUIs that represent that state there. So it's nice to see. One of the features I use in SourceTree all the time. I'm also a SourceTree fanboy, as if you haven't figured that out already. SourceTree has a really nice mode where you can say pending, and it shows you everything that has changed or is new. And it's showing and merging the things that it knows about that have changed and untracked. So that's where you would say, oh, that's a new file that I want to track. Yeah, I should probably get that. Because again, Git knows everything about the directory repo that you're in. Any changes you make, it knows about it. So it's really thorough in that regard. So things that are actually, so there are 3 different major states to get. The first one is things that are, this is regarding things that are already in the repo to begin with, okay? So you've already committed them. You said, I want to add this to the repo and have it tracked. So it says, oh, this has been modified. And so you updated a script to work on line. Now you updated it for mountain line. So that would be modified. So now it's not been committed and moved into the repo. So you modify a file, quit out of your text editor, right? Because we're all good system bins, and you know it's good to quit, so you don't have any open files potentially, all that good stuff, right? Then you move it into what is called a staged area. This blew my mind at first with moving from SVN. I'm like, why would I want to do this? I've modified it, I'm done, just want to commit it, right? Well, I ended up liking this feature a lot. I thought I would just skip it. You can skip it if you want to, but it's not recommended. And the beauty of the stage thing, I found it. If I'm working on a big project, in source code, whenever you're committing to a repo, it's very important to be nice to your future self. Let's say you've been working on a script for 4 hours. In that 4 hours, you go to lunch, you come back, you think, oh, I should change one more thing. Oh, I should change one more thing. Try to avoid that. What? Yes. Okay. We'll go back.
Why?
That. Okay. Yeah, AT&T says hi now.
It's working.
All right. So you go back. So with subversion control in general, subversion or get, regardless of those, you want to commit often. The reason you want to commit often is it allows you to step back in time very quickly, and it's very easy to say, here's a piece of functionality I want to add to this script, or a switch config. If you don't commit them at each individual time, the more changes you make, that's in one giant commit, right? If you commit them individually, it's very easy to step back. And also, if you don't want to step back, you see just the change. If you broke one thing, but you want to keep everything else that you did, right? I made a mistake. I was coding a big project, and I worked on it for 4 hours. I did not make many commits because I was being lazy. I was late at night. The sun was going to wake up at 3 a.m., so I went to get some sleep. And I said, quick and lazy commit, right? Well, it turns out in that 4 hours, I did a lot of changes. And if I had done them in smaller batches, and functionality 1, functionality 2, it would have been a lot easier for me to detect what I had broken in that 4 hours. So, lesson learned was commit often. It's free and easy. So, the stage area basically, it allows you to move things into stage area and compartmentalize the changes you just made. Let's say you have multiple scripts, like Rich Trout has a bazillion scripts, which are all awesome. Let's say he's working on 2 scripts and he doesn't commit, well, you've got script A and script B. They're not related at all, but let's say you change script A and you think of something cool for script B. You go and do script B. Git's going to show you both have changed. But it's better to commit the first one first and capture the idea of what you did in that one. Because if you're collaborating with others, they can then see very quickly, oh, script A did this. But if you lump them together in the commit, people, or the collaborators, are going to see and think they're related maybe. So staging your changes with the files that are related to a particular functionality or change you made, and then committing those, helps you compartmentalize your changes, also the mindset too. It really helped me when I was working through bugs with scripts or anything. MCP's not showing my clock timer correctly. Okay, well, let's fix this. All right, cool. Oh, I found this other bug. No, Justin, write it down, finish the bug, commit it, and then go back to that one and fix it. And then if the cut timer wasn't right, then look at that commit, see what did I do differently, and then it really helps compartmentalize that. So, all right. So basically, Git installer, it's actually the very easy install. Package installer, you can get it from git-scm.com. It's also included with many GUI clients, like SourceTree has an embedded version. If I use SourceTree, I use the one that's embedded with it, because I know they've tested a lot with that particular version. Git is updated quite often on the main website. You can use that too. Xcode installs an Apple Git version, a version of Git that Apple labels Apple Git. How they changed it, I don't know. It might be a different path. So if anybody else knows why they're doing that, I think it's because it's at a different path and they may have tweaked it for something they want to interact with Xcode a little differently. Because if you Git, what's that? Okay, that's good to know. That's fine. Yeah, I'll try. So Papine was saying that Apple's Git keeps or has modified the way that it stores authentication in the keychain for that user. And you can still modify. I've got a Git repo on a SSH server at home. I'm using SSH keys there. Server at work. One of my sysadmins installed a Git server daemon, and that authenticates differently too. So there are different authentication models. Thank you. Thank you. Yep. Yeah, definitely. Anybody knows anything, please definitely speak up. So after you install it, you want to run 2 commands. You want to configure the username. This is important to run, or else Git's going to complain to you and say, I'm not going to let you commit anything unless I know your name and your email, right? And it's easy to forget this, but a lot of GUI applications automate this for you. GitHub and SourceTree does that as well. These slides will be available as a PDF along with the videos shortly after the conference, we promise. Feel free to take notes, of course. Oh, sorry, if anybody wants to see that. And you also configure your user email as well. A nice feature really quickly about Git configure and your username configs. So I have code at work, but it's obviously for work, MCP. Then I have stuff at home that I'm working on for fun. That's using my Gmail account, for example. You can, for each repo, store a different username and email address for that particular repo if you want. So if you have some stuff outside of work that you use at work as well, your office, you can change what username and email address it uses when you commit that message. The reason you'd want to do that is, for example, on a work machine or a work repo that I share with my group, I don't want them to see my Gmail address. They need to see my work email address when I commit changes there. So that's one thing to be aware of when you do a Git configure. It's a very nice feature. And Rusty and I have done that accidentally too. I'll see Rusty Myers at Gmail and on our work repo. I'm like, change your username and do a custom config for that repo and fix it. It's easy to do. Kind of a nice feature. So what you do is then, first thing is you create a repository. So from the command line, you would actually create a directory, and then you would type in git init repo name.git. So the repo name.git, you don't have to name it with .git. That's the recommended style. It can be named whatever you want, but that's when you're in the name of the directory is repo.name.git, and then you would initialize that. And what that does is it sets up the necessary files for Git in that directory to track, and it knows that it's a repo. It creates a .git directory as well. .git config, I believe. I think it's .config. But there's a directory there. You don't see it in the Finder because it hides files and directories by default. Yeah. All right, so I decided to read my bullet. I'm not actually reading my slides as much as I should. And so then you would add the files to the repo. That means that they've not been added to it at all, and you would actually commit them to the repo. So as we mentioned earlier, there's a staged area. So why do you want to stage anything at all? Again, it's a great way to compartmentalize the changes you're going to make. Then you can commit them, and then you know they're good to go. So it's a good way. It's really helping the organizational flow of moving things into the repo. And then, so how do you add modified items? Well, you cd to the directory, and then you would say git space add dot, right? A lot of GUI apps wrap these commands inside the GUI. So I'm very heavy in the terminal. I'm a programmer, but I still like to use the GUIs because it wraps a lot of this. But it's good, it's essential, I think, as Mac admins to know how to use the terminal, because in case the GUI app doesn't work correctly, you need to know what to do and jump into the terminal and figure it out. So it's always good to know what it's doing on the back end, so you can get the concepts and you can glue it together. And the git add space dot will do everything in that directory that is changed. So this is when you're first creating a new one. You know you want all these files. You don't need to worry about. You know for a fact you want everything that's been dropped in there. So you add it to the repo. So you do a git add, does it recursively, and it adds it. Now there's a way to know. And so Git can tell you, okay, I know what's changed in the repo now. So you can tell it, well, tell me the status. And so it'll report the different states. On track, again, it's something that doesn't know. You haven't told it to add it yet. Then they're also staged, which we've mentioned. And those are the true. Of course, there are the ignored ones. So occasionally, if you'll see, hey, I just added a file here and it's not showing up, check your .git ignore file. It might be deleted, not deleted. Sorry, it might be ignored. Git ignore can also not just ignore file extensions, or wildcards or anything. Splat.log, if you have a lot of log files. Yes, I'm guilty of a lot of log files. I think they're good. But Rusty likes to make fun of me because they're verbose. I like that log files. Anyway, you can also delete, or why do I say delete? Sorry. You can also ignore any of the files under a directory. So that's kind of nice as well, right? Because you may want to ignore everything in a certain directory. And then you can have in the repo .ignore this folder, so you can always have files there that you want that are unique, or cached files that you never want to be in the repo, things like that. Like with Xcode, you can have a project settings for a particular user. You don't want somebody else's settings, so you can just ignore those types of settings, things like that. So when you do a commit, this is telling Git to, with your -m is the message. That's where you would say what you changed, what that commit's all about. And you want to make sure that when you do that, you commit often. And come in, it's like, yeah, come on, it's easy. I know, initial reaction, I always thought years ago, I'm like, why do I want to do Subversion at all? I was like, I don't see it, I don't get the point. Back in the day before I used SCM in general, I had, how many people have you done this? You don't have to raise your hand, that's okay, I'll confess. I would have last image config, and I'd have, like, all the versions since the creation of time, right? At 1.0, this had separate folders on my hard drive with each of those versions. Yuck, it was not good. And it was a mess because if I'm searching the Spotlight, trying to launch my application, I'd launch this version, oops, well, that wasn't it. I changed something, oh no. So if I wanted to replicate issues in the earlier version, I'd have to go through Time Machine and do a restore, and the, you know what, right? So commit often, put them, and use the SCM the way that you want to. And, so make sure I'm not forgetting something here. Yep, and so that's going back to the point again that I mentioned earlier, commit often. And you're thinking, well, I don't want to commit for every letter I type. Well, no, of course not, you don't do that. But you would say you're fixing a script to make sure it checks for a file to do a reboot, or you added a bunch of machines to a new lab that you have, and then once you've added all of them, then you would do the commit so that your cohorts or your coworkers would see that and pull from Git. They'd see that update, and it's good to go. It's very encapsulated. The nice thing about Git comments, too, especially in SourceTree, I'm more familiar with it, GitHub's excellent as well. It's very easy to search commits and files that have changed. So you can say, I fixed a particular bug. Let's turn off Wi-Fi. Thank you. Thanks. You could search your commits and say, oh, I know that was related to Jira ticket number 548, right? Then you could search your commit messages, track it, and it says, oh, commit fixes this bug in Jira, track it number 548. Cool, that's it. All right, that's what was fixed. So it's a really good way of also tracking bugs in Jira and other ticket systems as well. Yeah, and the last thing is mini victories. It sounds cheesy and stupid, but it actually, you say, yeah, I committed that. That's been locked away, and committed. So again, that goes back to SCM. It was one of the most liberating things. You get something working, and you've locked it away, and now you feel safe again to take a huge leap in case something doesn't work. And if it doesn't, you have this thing you can fall back on. If you don't have it in SCM, it's restored to a previous version. You do crash plan or time machine, and it was a subtle thing I did not appreciate until I started using SCM in general. I thought, oh wow, so it's kind of scary or sad. I actually look forward to making a commit and Git because I know I can move on to the next thing and take bigger chances and have bigger rewards as well. And changes. So commit really is meaning. Well, I want to make sure I understand what that means. What does it mean when you say commit? This should have been earlier. I apologize. It means you're saving those changes to the repo, right? So you're saving the state of the document in there as well. And if you're using wikis or anything else, they have revision control as well. You're saving the last state of that document, and if somebody goes in and wants to edit the whole thing and delete it, okay, fine. I'll revert back to the previous commit. We're good to go. Stashing is another thing that's really nice. So I recently had to do this, and it was quite handy. Again, with the MCP, I'll use that as an example. Because I hadn't tried stashing yet. It turns out it's really simple. Stashing is for when, let's say you're working on a script, and you aren't quite sure that the code you have local is really going to work. And you're like, well, and you run your code, and it has a bug. And you're thinking, oh, did the new code I just do cause the problem? Or was it existing in the previous version? Well, if it's in the current code that I'm working on right now, the changes I've made, I don't want to commit those to the repo because they could be bad, right? So what you can do is on your local machine, you stash this. It says, okay, I want to keep these locally, but I don't want to commit them because it might be good code. Could be bad code. So I'll keep it because I'm not sure yet. So you stash it, it returns you back to the previous commit, and now you can test your script and replicate the issue. And if the issue happens again, you know it's the script already and it already existed. So what you do is you have moved the stash out of the way, reverted, fixed that bug, replicated, of course, first. I'll just start shooting on trying to fix it. Who's done that? Okay, sometimes. What your gut tells you sometimes. Anyway, use good judgment, of course. But you replicate the issue, you fix it, then you restore the stash and you can merge it and you'll say, here's what's different from what you just did. So stashing is really powerful and it's done locally only on your local machine as well. So it's a really nice feature to use there as well. One of the other cool things I get about, cool, should definitely do that. Okay, so Git, of course, knows what's changed. Well, that's great. It can show you a file status of this has changed whatsoever. Well, you want to actually see what's changed in the file. You don't want to just say, well, I know it's changed. Show me what the differences are in the actual file. This is where it's really nice to. You can do this with the command line, and it looks okay. It's kind of cryptic, but they'll say plus for a change or minus or otherwise. But in GUI apps, I actually prefer using the GUI for this one. I mean, I've used diff and all the other, and you can do it side by side in the terminal. So I know there's some command line junkies out there. I am still for a lot of things. But for GUI apps, I actually really like Kaleidoscope. File merge that is included with Xcode is a good choice. Changes.app is another good one. But Kaleidoscope seems to be the newest hot one on the market right now. And it works very well with Git. And also does merges very well. There's a three-way merge and some things. So, and it's really nice. It's very pretty. Shows you differences. You have different ways of viewing the data. But Kaleidoscope, it's not free, but it's very cheap. Excellent, excellent application for viewing differences. So, I don't know if I want to mention one thing about. Okay, really quick. It's not on the slide, but I'll definitely mention it here. When you're looking at differences of files, there's something to be aware of. Git works on all platforms, on Linux, OS X, and Windows, right? SourceTree is also coming out, or actually is out now for Windows. I haven't tested it there yet, but it's a nice application there too. Macs, of course, Windows, of course, has different line endings than Macs. And Macs, the old style, used to be CHR13, hard return, line feeds. I see a few people nodding their heads. You know, you have a line feed plus a carriage return. So anyway, what is that? Why am I mentioning these things? Well, if you, Git is really good about saying, and you can change the default of what it's looking for line endings. Let's say that you're editing a file on OS X, and then you have another person on Windows saving it, and they save it, and it suddenly saves it with carriage returns and line feeds. Well, OS X uses CHR10, CMIS line feeds. And Git can either say, whoa, this whole file changed. All of these endings are different. You don't really want to see that, right? Because on Windows, those are the line feeds you should use. On OS X, these are the ones you should use here. And that's perfectly fine. You can configure Git to ignore those, and it understands. Code hasn't changed. The line endings are different. This person edited it. Ignore those. So it's a really nice feature. It'll tell you everything else that's changed. So you can configure Git to show differences between line endings. So if you ever get to that and you're seeing some weird stuff with this, be aware of that. It's an easy thing to work around. It's a Git config, and it's a supported thing too. All right. So Git branches. This can be a complicated topic. We will talk about it more in length in the hands-on as well. I'll be glad to talk to people, of course, after the sessions too. We debated on how we want to handle branches because it can be daunting for some folks. Because Git in itself, and if you're completely new to SCM, you don't need to use branches at all. You don't. In fact, it's probably better not to use them initially until you get you're comfortable with Git in general. But what they are is basically separate lines of development. So the master is the default branch within Git. Okay. So anything you commit, it's going to be called the master. Typically, people will just probably add the main master branch, and that's fine. But let's say that you wanted to have the main master branch is for release only to your customers, okay, or your machines that you support. Well, you know that one definitely, you'd only want to, one of the theories behind branching, is called Git flow, and it's a really interesting one. I'm using it. Some days I have to be very careful on how I do it, because you can, it's powerful, but like anything powerful, of course, you need to fully understand it. So, and I'm almost there. I think I got it. Master basically would be the version that you're always going to be releasable, so it's always releasable. Hot fixes would be, I want to make a new branch and not change the master. So if one of my colleagues says, hey, I'm going to check out the most current version on the branch, you can say, that's great. Branches allows you to basically take that line of code and copy it to another branch, make your changes, and people, others viewing the repository can check it out, and you're not affecting what they're going to be seeing. You have plenty of time working out locally. You can commit it to your local repository, do changes there, test, and then you can say, hey, Scott, I just made a change on branch bug fix number 1. Can you check it out and take a look at it? And you can say, sure. You can check it out. We don't affect the main master branch, so if others wanted to get to it. So we can work off the side in the same repository and share the branch changes, and then the others can then use those and leverage those and test them for you and make sure it's good. and then he can revert back to master. And when I'm done with it, move it over, merge it back, and then it commits those changes to the master branch. I know, so you can see there's a lot of branches here. I looked at it and I'm going, what? I don't know if so that's why this is more of an introductory course session on Git. So branches can be confusing at first, but in a nutshell, they're just another way of having another track of scripts. Think of it as another folder if you want to, that has different files, but they're really powerful to use and something to want to look into if you haven't already, if you're familiar with Git already. And if you're new to Git, take a look at it once you get comfortable with Git. I think you'll and realize the power of them. They're very, very useful. All right, so next, I'll pass it over to Scott. He's going to talk about some GUI clients.
So before I get into the GUI clients, we get back to the branching thing. I did find a cool animation type game thing. So when we get to the hands-on type thing, we'll bring that up. We can kind of show everyone and run through that real quick. But doing about GUI clients though, so I think everyone kind of works out the GUI stuff, but we will go over some terminal stuff and the hands-on just so you get kind of foundation and background of what's actually going on when you're doing, items in your GUI clients. So GitHub. I think everyone's probably heard of GitHub in this room. They have some GUI clients that work with OS X, Windows, and they do have some mobile clients that work on iPhone, iPad, Android type things. The mobile clients, though, will only let you view items, so there's no editing of code. There are some paid apps that I did notice the other night browsing, especially for iPad, that you can get if you want to actually edit your source code and then kick it back to your repository and stuff. Totally up to you. I think it's a lot easier with the iPads now that they're coming out with like Bluetooth keyboards and keyboards built into the cases as opposed to trying to type out code and stuff. Autocorrect will probably kind of kick you in the butt on that one and want to change all your stuff back. But those are, GitHub is a really good one too. I think for anyone that's really looking to get in and do beginner stuff, it's real basic. There's only, I think, like 3 or 4 buttons on the left-hand side that you can click through to do all your items in the GUI client. So if you're looking for something real basic to do, I'd recommend the GitHub client. It's free and it works, cross-platform among everything. Some more, as Justin mentioned earlier, he's a SourceTree fanboy. I'm in that thing too. Great product from Atlassian. It's totally free too. That works, OS X, and they recently came out, I think maybe a month or so ago with a Windows version. So that's another great one. The other one that we put up there, Tower, they do have a really good Mac client, and I think you heard Justin chuckle there a little bit. You can get a 30-day demo of it. It's not a horrible client. The layout, it looks really pretty and everything. I'm not a huge fan of it. The reason I think I'm a big fan of SourceTree as opposed to Tower is that in SourceTree, you can go in and add, say, for example, I use GitHub, so I can go in and add my GitHub account, and then I can see a list of all my repos that I have and decide which ones I want to clone. Whereas with Tower, you have to actually go and get the full path of everything individually for each repo, and then plop them in there and do them that way. So, but it is pretty. It is not a free app, though. I think it's $60 for Apple, for the Mac. But some other ones, though, that we've heard people use is SmartGit, Gitbox, and TortoiseGit are some other good ones. And if anyone else has any other ones, feel free to share them as well. So, talking about remote repos. So, what is the difference between a local repo versus a hosted repo? So, with a local repo, you're just doing that repo, say, on your machine. Whereas I think the big benefit for that is if you're traveling a lot, so you're stuck on a plane, a train, something along those lines. That's where you would do that local one. So, and then the hosted repos where you're actually taking those changes that say you've made and you're pushing them to a remote location. So, either your own repo server that you're doing or a place like GitHub, Bitbucket, items like that. And then you can also do cloning from a remote host. So you can clone someone else's repo or your repos down to your local machine to be able to work on them. And then also we discussed earlier about branching from a remote or local host. You can branch items. So if you want to pull off something and then put it into a different version number or you want to take a script and you want to edit it to do different things for different groups in your organization. That's where kind of branching really comes in key. Some other remote repos you can do. So you can do self-hosting ones. So anyone that's doing any type of Linux administration in the room will recognize the first one with SSH. So you can have your own SSH server, and also you can have your own HTTPS server. So and those are two of the big ones, especially for items like GitHub and Bitbucket, and mainly because you got that security that you're doing with that encryption level with SSH and HTTPS. You can also do a self-hosting Git protocol, and it just runs as a daemon. But the only thing, the problem with that is it doesn't provide any type of security or authentication security, I should say, with the Git protocol. So if you're going to do your own self-hosting ones, we recommend that you do something along the lines of SSH or HTTPS, depending on if you're more familiar with the command line or a browser type window. Some more remote repo stuff. So some third-party ones. As I mentioned before, GitHub, so I guess you can call me a GitHub fanboy if you want to throw me in there, but Bitbucket's really good too. Google Code, they have their own too that you can use if you want to use them. Code Spaces and Source Repo are some other ones. Assembler and Gitorious are also two other good ones. And I believe they're all free that you can sign up, and they'll give you a certain amount of space that you can use. Now, for GitHub, we'll put this in the slide notes whenever we go to hand them out too. GitHub is doing a thing for any female programmers, so I notice we do have a good bit of female population in the room, which is good. They are offering free private repos for anyone. So you have your public repos that these sources will give you, and then you can use those. So those are all public, so everyone can see them. But you can pay for private repos. I think GitHub is like $7 a month. But for the ladies, they are offering, they have an agreement with some organization where they're giving private repos for free. So I'll make sure I include that. I don't have the link on the screen or anything, but I'll make sure we put it in the slide notes so that anyone can get those. So I thought about doing private stuff, private repos, just so I can keep everything in an item like that. So if I see a hand, no hand. Okay. So lessons learned. And when we get through the lessons learned stuff, feel free to chime in with any of your lessons learned. So these are the kind of ones I think that Justin and I have experienced, or other people that we know have talked about. So this could, be a nice fireside chat type thing too. So if anyone wants to do a BOF later tonight, I won't be here, but I think Justin will be, so he would probably be more than willing to. So I think the biggest thing with lessons learned is a lot about naming things. So for example, your branch names, what you name your branch names, you're not just going to name it branch 1, 2, 3, items like that. You want to be very descriptive, or not very descriptive, but somewhat descriptive, so you know that this branch pertains to what it actually does, or what that script does, or what that documentation is for. So you can't use no white space naming. So either you got to chunk everything together and differentiate things with capital letters and stuff, underscores, dashes, I think, or acceptor. Supports hierarchical naming. And Justin, you kind of put that one in there, so I don't know if you want to cover that one, please.
Basically, that's just a nicer feature of doing wildcard. So let's say, for example, you had a bunch of bugs in Jira or another ticket tracking system, and you want it in your bigger organization. And I believe, I know Atlassian does this, and I believe Firefox do this too. You can have a /bug, and the slash that's in it, you can't end a branch name with a /, but it can be in the middle of it. But what it means by hierarchical names is, again, a wildcard. So you can have bug /PR-17 in an example, or show all branches that have the word bug in it /splat, and it will show you every single bug that's listed, or every branch, rather, that has that in its name. Kind of a useful thing there, too.
Okay.
I saw the tag one, too, so if you want me to help there, I can.
Yeah, so getting back to, I'd said before, the no white space thing, and you can use the dashes. You can use them anywhere in there, except for the beginning. You can't use them there. And also with the dot, you can't use the dot in any of your naming and stuff like that. So, yeah, tags. Tags are another one. They kind of fall in line with the commits. Like, you want to make sure that if you're going to use tags in your Git stuff and in your commits items that you want to make them descriptive as possible. And the big thing with tags, and I think commit messages is, especially with like the SourceTree and items like that, you can do searches on those tags then. So if you tag something and then you need to search back for all the tags, them all together for you, and they're searchable text then. Bless you.
Tags are useful also for like major release versions of something. So if you have, your fall 2013 script you're going to put out, you could say tag fall 2013 script 1.0 or something like that. So it's kind of a nice way to use it to tag a point in time of a commit. So it's useful for that. You don't have to use tags, but they are handy. So like the software, you could say 1.0, 1.01. And so if you ever need to, you get a customer saying that a script or a lab machine is having problems or your application's not working quite right, you can say, oh, I need to revert back to that version, build it and recreate the problem. So it's an easier way to, because you'll have a lot of commits, and it's easier to do just a few tags now than with a major release. Something about tags really quick too for those in the room with Subversion. When you're using Subversion, I did this in the previous repo that I had. Sorry, Scott.
No, all yours.
It's just something to be aware of. There's a utility that you can convert SVN to Git. In fact, that's actually what it's called. It's a good utility. And then I had a gigantic SVN repository for West Image config, and I moved it over, which was great. It worked. I had a lot of tags in SVN as well. In SVN, I had tags with spaces in it, which is okay in Subversion. Git, though, it turned it into %20s. And so my tags were ugly in Git. I mean, there were like tons of them. I thought, oh, boy, that's not fun to look at. In Git, though, it's very easy to clone. What you do is, so I stole one of those tags, because they are still useful to me. So if I get something saying, this version doesn't work. So what you do is, you can select a tag in Git. It's really easy to do this in SourceTree, too, and the command line as well. You select the tag, and you say clone it. And it remembers the commit message you have. It says, okay, make a new one, clone it, and then you delete the old tag. Not deleting code. It doesn't change the repo at all. It's just a tag. It's just metadata. So if you delete a tag by accident, it's no big deal. You didn't lose any changes. So you would clone it, delete the old one, and then you're good to go. So, and the tags use annotated thing most of the time. There are tags in Git called lightweight tags. I won't go into it too much, but they're generally not recommended to do that. So annotated is the ones you want to use in case you're looking for tagging. Annotated is the one that people are recommended to use.
Yeah, tags, unlike commit messages, are not required. We are going to go over tags in our second hands-on session, so we'll do them show you. I think we're doing them at the terminal, maybe. I know we're doing them in the GUI SourceTree client.
Yeah, they're easy.
So we'll go over tags and show you, how cool they actually are and stuff. So some more lessons learned. So I think the big thing is these that I've been stressing is making sure your naming conventions are right, and take the time to write those good commit messages and make sure they are descriptive. So if you ever do need to go back, either it's last week that you need to go back, or if it's a couple years you need to go back and remember, what did I change on this code, or what did I do to do this so that I can apply it to this script. As Justin, I think, always says on the second one here, is always be nice to that, to your future self, so that you do know, what did I do in the past, that I, need to change or apply to this one. And there will be a time, like I said, that you need to search through these commit messages and either use them to apply to another script or another project you're working on, or if someone asked you, how do I do this? And you're like, I did that one time, but I don't remember how. So if you write those good commit messages, you can go back and then search and then find out how you did that and, get that kind of +1 for the day. More lessons learned. So using a version control makes you more mobile, and you can test scripts, across multiple platforms. Getting back to the thing I said before, so you can test these scripts across these multiple platforms if you're using a mixed environment where you're running, 10 dot something, 6, 7, 8 in your environment. So you can actually go back and then, test them across all of these. Commenting helps you to clarify your comments, design flow for, code review. So if you have those comments in there, I think it helps you, think through your whole process of what you're doing and writing your code. And then Justin had said before about moving files in Git is much, much more easier to do than Subversion, whereas if you moved them in Subversion before, Subversion just freaked out completely. And we can do a demo of this in Git. It's really awesome. Justin showed it to me. when we were doing this session. Git knows, if files are moved. It doesn't, or if you're even renamed, it looks, at that bit level type thing as opposed to, a file name and stuff. Does anyone have any good lessons learned they want to contribute to us? Or to the group? Nobody? Nobody. All right, I got some swag. I don't know if anyone went up to the Code 42 booth upstairs. They're giving out USB car chargers. Someone wants to give me one, I'll give you one of these.
Bribery.
Come on, I'm bribing.
I know we're all in the food coma.
Yes, I know. I said I was hoping there was not turkey for lunch today because everybody would be sleeping in here. Luckily, there wasn't. So, no one? I gotta keep this? Yeah. I do have two in my pocket too. So I mean, if you both want one, thank you.
To that point though, is I also found a blog post once to use Git to update websites. So Git actually has the ability that if you push a Git, do a Git push, and push it through your remote repo, you can actually set up scripts that are something like upon receiving a Git contact, it's called. You can set up certain scripts that run at certain Git commands. So for example, when you Git push from a web server, the Git repo is in /op or something like that. And then the script will actually copy it out of the Git repo to /y/www.ssl. So I've got this really cool kind of workflow, I can't really take out credit for that. I'm just going to blog post somewhere online. You can work on your website and your working machine, you Git push, and then the script will actually update the website itself, and then push other scripts that goes down. Git is very powerful, and it has a lot of really cool kind of back-end scripts, scripts that you can add as well.
Yeah, thank you guys for that. Yeah, and I think the big key point of those two comments is that what you can use Git for. It's not just for scripting. It's not just for documentation. I mean, he's using it for his monkey stuff. You can use it for, HTML pushes for stuff like that. So, I mean, there is a ton that you can do, with Git and use it to control, and, really add like comments in or tags or commit messages in and stuff. Did you have something?
Well, one thing I was going to say is I know we talked a lot about a lot of advanced stuff. A lot of folks who are new to IT or just Git in general or SCM. You don't have to do any. You can do this completely on a laptop standalone. You never have to use a server at all. I just want to stress that because that's pretty huge because it's an easy setup. A lot of things, sometimes have heavy server requirements, and other things you don't have to do that. But the other nice thing about, again, the distributed part, again, to sell over Subversion, folks. Great as that is that
yes, we're trying to convert you all to Git today.
Yeah, no, it didn't take much for me. It was, I had to wrap my head around it. And Joel on Software gave a really good blog about. He was the same as me at the time. I was like, I'm not moving away from Subversion. I like it. Git, I don't want to mess with that. What is that? Oh, you do that? I don't care. Oh, you do that? So, and he had a great article about talking about how he was really, like a dog going to the vet. He doesn't want to go, right? So, and so what I'm saying is, Git was really nice when I was traveling, especially because otherwise, if I didn't have a network connection, if Wi-Fi isn't working, I could still do local commits on my laptop, and I didn't have to have a network connection, and I could keep working and capture those changes. Then, whenever I got to a network connection, I could then say, "Am I ready to push this to my central repository?" Yep, sure. With Subversion, I could not do that. And what I mean by couldn't do that is, Subversion, I have it local, I don't have a network connection, I just made a bunch of changes, I can't commit those. locally and then push them later, I have to connect to the network with Subversion to commit those. What am I going to do for 8 hours when I'm waiting for my flight that's been delayed twice? Okay, food, and then I'll just do people watching. That gets boring, right? So Git enabled me to do a lot more commits, be much more mobile, and test it much more easily on different machines as well. So the distributed part is huge. Hard drives are bigger now. Of course, SSDs are getting there. And so that was one of the lessons learned that I had out of using Git over Subversion, too. So wanted to mention that.
Yeah, make sure if you're not using a remote repo and if you do want to use Git for just a local thing, that you have some type of backup plan implemented. So if you stop upstairs, and some of the guys up there at the booths will be able to go over some backup plans. Yeah, Nate.
Something else I wanted to bring up was there's an open source project called Git Lab. It has a very similar web interface to GitHub.
Yeah.
So you can set it up on your own local box and use it kind of a server repo.
Oh, cool.
But then, like I said, it has a very similar interface to GitHub. I believe they somehow work together. The code is very similar.
Okay, for the recorded video, you were mentioning GitLab, local installation. Nice. Okay, that's good to know.
Yeah.
One thing I want to also mention too. Sorry, Scott. We're doing lessons learned type things. So
Yeah, it's open.
The Git, if you're doing a local repository on your local machine, it is not a backup. Okay. A lot of people think, oh, Git's automatic backup. No, it's not. It can facilitate it, and if it's pushing to a server, to another machine that has a different hard drive than the one that's in your machine, of course it does, that is a backup. So I don't want people to think Git's a backup even if I'm running it locally. No, because if that hard drive goes and you don't back that one up, then you're done. So just want to make sure the distinction, people understand that it lets you revert to previous versions, but it's not a backup until you back up that machine, the time machine, or a crash backup, or something else, or to a host.
Yeah, we'll include that GitLab too in our slide notes, as well as if anyone, I know there's a couple of hands that went up for the SVN folks in here, so if anyone's looking to move to Git now after this presentation, we'll include some of the links and some of the stuff in there as well too. So.
Mm-hmm. That's an excellent point. Yep. I like that methodology better than the other one I heard. It's not to rip on anybody. And I was doing this initially too. Before I had to get server set up through SSH, I was backing up completely to the local repository was in Dropbox, and then I had all machines getting it that way too. So that's a cheap way of a Git server. But I like that idea though too. That's you were saying the same thing. So yeah, using Dropbox also has its alternate version. So that's another way. In fact, I used Crash Plan to restore a Git repo because I didn't, when I was first learning it, I'm like, oh, I really messed this conversion up from Subversion to Git. It didn't go so well. I tried the previous version. Oh, I do. Crash Plan. So.
Yeah, if anyone doesn't know what they're referring to there, so on your Mac, so if you install like the Google Drive app or the Dropbox app inside your home folder, it'll create a Google Drive or Dropbox app. So whenever you're doing those repos, if you save it, if you do a pull and you save it to one of those folders, then it gets pushed to your remote Dropbox or your Google Drive. So in essence, you do have a backup copy then. So resources and training. So obviously the official Git site that Justin mentioned where you can actually get the install, they have excellent documentation. So git-scm.com.
There's a really good PDF documentation there too. Because reading on the iPads and things flying back home. They've got a great PDF you can search through. It's from 2009, but it's still very applicable. And they've got some good cheat sheets. We'll be handing out cheat sheets too here. So for those who are staying out for the lab, we'll have that available too. The cheat sheets there are really good.
Or if anyone wants them that's not staying for the second session.
Yeah, we'll be glad to hand it
Feel
out.
free.
You can get off the web. It's nice to have the copy.
Yeah, even though it promotes Tower.
Never having used it at all. I'm trying to understand the commits, what kind of methodology is used for this commit. Is there also some sort of auto commit, like after a period of time, you auto commit?
Generally,
You just have to.
it's generally something you want to initiate yourself because let's say you're. That's where I would use an automated backup system that's doing an incremental backup using Time Machine or Crash Plan. Commits are you only want to commit to a repo when you know that the code is good or that you're ready, that you're done with that change. So commits are different than a local copy saved. Like an oh god, I don't have a previous version of this type of thing. That's where Time Machine and CrashMan and other systems that back up your code is like that. But commits are definitely save points in time, but only commit changes when you're done and ready to commit it to that. If you're worried about that, oh, I just made a commit and it's bad, you can still have Git say, oops, that was bad. I want to revert to the previous commit and try again, or view the differences because part of that commit might have been good, some of it may not have been. That's where Kaleidoscope would then be a really great difference engine because you could say, oh, this part of my shell script is really good. This part I completely messed up. Restore the previous version of this and leave that in because that's good. This is bad. So commits are only when you're ready to actually save it, but you can also revert back easily if you mess something up.
Well, I was thinking of the example that you had where you're working on it for 4 hours. And
Yeah.
you hadn't done anything with it that after a certain period of time you could changes being made that it would automatically commit and come back and say, oh, at least you would have some sort of a get back to in that 4 hours.
Oh, I see what you're saying.
Yeah, I don't think there's any type of auto, like if you're looking like Word and stuff has an auto save feature, I don't think, any of the, at least SourceTree doesn't have anything where it does like any type of auto push or auto commits. Maybe.
It's not designed that way. Yeah.
Yeah, I think the big thing with Git is that you can revert, so they're not too worried that if you push something and it's screwed up, that you can always revert, assuming that your initial base is correct. Then you can always go back in time, type thing. So.
That does what? I'm sorry. It does.
Yeah, like the version.
Oh yeah.
Yeah, I think it's just called versions.
The front end is
or version.
Time Machine, but you're talking about the back end engine. That does
Yeah, and like 10.7 they implemented.
Right. Yeah. Yeah, I'm blanking on the name too. I know what you're talking about. There's this hidden directory that keeps track of that for each user, and it's in a different space.
Yeah, I think it's just called version or versions.
Yeah,
I think it's along those lines. I think they made it real simple. So,
Yep.
Yes, you had your hand up.
Yep.
You're talking about stacking and committing. Does Git go back to different versions? What is committed?
Right.
Why would you really need to stack if you go back?
Yeah. Sure. Yeah. I'll go ahead to pick that one up.
I mean, I'll add something. I mean,
Sure,
I think for stashing is say you, there could be two ways to do something. So you you do it one way, you stash that code in there, and then you try the other way. And then with stashing, then you could flip which either way you want. I know you recently did stuff with stashing.
I'll take another stab at it because you have anyway. Stashing never commits it to the repo. So if you stash something on this machine, and this is your home machine, you go to work, your work machine won't have that in its stash because it was never committed to the repo, right? So the stash is basically, I've got a last commit, I've made some changes since then, and there's a new bug or something that's happening. You take what you changed just now and you move it because you're not sure if you want to throw it away and never commit it to the repo, or if you want to actually use it. So it's basically saying, I've got a commitment A, I've made some changes, I see a bug. Move it out of the way, revert back to this version, and try to replicate. And then you can throw the stash away like it never happened. Or once you've replicated it, you can bring it back and say on this local machine where you stashed it, not on any other machine, bring it back, reapply the changes, and say, okay, now I'm going to take that, apply that stash, changes the code, and then you can recommit it at this point. And now all the machines that pull from the repo will see that last commit. So think of it as like a
way to not pollute the commitment.
Exactly. Yes. It's a very I'm probably not doing justice on it. I'll be glad to show you too here. We'll definitely. If you're staying for the next session, by show of hands, who's in the next Get Hands-On Lab? It's okay if you're not. Well, yeah, there's other great sessions too. So I'll be glad to show you too. And if we have any time before 10 minutes is up, I can show you a demo and show you how that works.
Yeah, so some other resources training, we'll just wrap it up real quick.
Yep.
So try.github.com, it'd actually walk you through doing things like that we're going to kind of do in the next session, creating a repo, making a change, adding items like that. Atlassian has a good write-up too on their website, atlassian.com/git. Atlassian is the ones that produce SourceTree and keep it free for us. Some other ones, the first one, the Code School one, is just like the try.git one. Code School has a bunch of stuff if you're looking for things other than Git as well. Check them out. Git Tower, they have some things too on theirs. You can use the link to get that one. Do you remember what the last one was we put there for?
I think we'd have to follow that one.
Yeah, the last one, if you do, it was a resource that we found that had some huge URL.
Yeah, it's a woman developer, I forgot, but she was talking about branching and how it's useful for collaboration. It's a good article to read.
Yeah, so if you're looking for some other ones that are, you can pay for, especially if there's any Penn State people in the room, lynda.com, we have, subscription to that, but they have some awesome videos on there. Git Essentials Training is an awesome intro.
It is A+.
Yeah.
The name of the person who escapes me, so if you're in this room, thank you. But it's fantastic training. It's a lot of fun, too, to put it in the QuickTime mode, because you can play it at 2 times speed and it sounds like a chipmunk, but if you get through like a 6-minute video in 2 minutes, so if you have a lot of caffeine.
Yeah, if anyone's good at reading
We're all
lips.
really smart people, so we'll have no problem getting it.
Yeah, so, and then O'Reilly has some good stuff. If you look up I don't want to butcher the names, but if you look up that, McCullough and Berglund, Mastering Git, that's another awesome resource as
Stay on that one.
well. Yep.
We actually bought, in my group, the video training for that. It's fantastic. They also wrote the book on Git. I should have brought it with me, but I'll bring it to the lab. It's an O'Reilly book, so of course it's a really good one. Then you also get the PDF of that. It's yet another great resource, so that's an excellent training material for Git. Found it pretty easy to use.
Does anyone have any questions or input that they want to do first?
Yeah.
Sure.
Then generally recommended not to do that. You can. I'm actually doing that for versions of major build releases of my particular application. So you can do it for that, yeah.
That ties into my directly related question.
Yep.
It sounds like commits are per file, so how do you track integrity from type?
Right, sorry. Commits actually can contain multiple files. It's not just for one file. Sorry. Yep.
Commit that represents a still included version of the file.
Correct. Yes. The
Yeah.
commit basically says, I changed a bunch of these 10 files. I only want to include 6 of them. Move all of those 6 into that commit, and then that commit contains all of those 6 changes.
Right.
Individual files. Yes. That's a good point. We'll update the slides to reflect that.
Yes.
Good point.
Yeah.
Yep.
On GitHub, they sort of have these puppies that are forking on GitHub. Is forking just floating these service points, or is it
It's actually it is not a branch because the branch would be contained in the repo that code already exists in. Forking is basically, you're making a copy of and starting with their repo and making a copy for yourself.
do you bring all their branches with you?
I don't know. That's a good question. You probably might be only cloning the branch. Does anyone in the room know? Fine.
It's more on a per branch basis.
Is it per branch?
After you call the branch.
Okay. Pretty much.
Anyone else have any?
Okay. Yeah. Good question.
8 again?
Nate?
2 hands?
Oh, thanks.
No, go ahead.
Yeah.
No, just on the other comment about the compiled binaries. If you were to use Git for documentation and maybe we're working with a pure text file, maybe an Excel file or something like that, I mean, how is something like that handled, or is Git not maybe in the right position?
Anyone want to chip in here? I can take a wing at it. Excel's potentially going to have, if it has chart another binary data in it, it's probably not the best to use for that. But you can try it and see. So it depends on how you save it. No, it's a good question. Dropbox might be a good solution there, or Google Docs, because then it's going to be, otherwise Dropbox you get conflicted copies of somebody's saving. So I'd say try it.
Good.
You save your Excel and CSV.
I thought that about
Yes,
Yeah, that's true.
Point. That's true. Excellent.
Yeah, if you save it in a...
That would be fantastic. Yeah, actually, that's a really good point, because then in the commit messages, in the commit messages, you could do a diff and say, what was changed in this document, versus, in the diffs, so if you have an application, I develop things in Real Studio, they have multiple versions. You can save the project file as a binary blob. Can't look at the diffs on that very easily. Oh, let's see, what's text A6? Oh, I don't know what that is. versus text, where you can save in a version control program format. Always, if you can, save in a text format, then you can do the diffs a lot easier. You can even look at XML and do the diffs on XML files, and that's pretty easy too as well. So it's pretty handy to see different configs. And I was talking with Tom Bridge. He stores switch configs, I believe, for VLANs and other things, text files. Yeah, and Git. It's perfect for that because his colleague, when he's out, is like, uh-oh, this one is not working at customer, and they have a repo just for that customer's switches. It's like, you can search the commit messages. Okay, change it. Oh, here it was. He changed it last Friday, now it's broken, so I'll blame him later, and I'll fix it now. So it's useful to see changes that were committed to a particular repo.
Yeah, do look at the apps that you might use. Real Studio is an example just because Justin and I both use it. You can save in a non-binary format, so you can save in a VCS, version control system, and you can actually then use Git, a Git client, and then to push to a repo. Just like Excel, you could save into that CSV format. So do look in your apps and see if there's an option to save as some type of version control or text related if you're looking to use those in a Git environment. So Nate, did you want to go next?
Nate, then you go.
Keep passing it.
Just a resource I wanted to bring up is
Yep.
Travis Tax CI.
Okay.
You can actually hook into the GitHub repo. So some of the mentioned actually Python code instead of just using it for scripts. It'll actually check out your latest commit and try to build it and give you a build status.
Oh.
You'll actually notice some people on GitHub will have a little dynamic badge that says current build working or current build failed, something like that. So it's actually another really cool resource if you're actually writing code that needs to be compiled.
Yeah.
And we do have, it's all VMs and stuff, but we do have OS 10 83 VMs. So if you ever need to test anything with Xcode or
Wow.
I've done others that you can do garbage testing
Okay.
with it and stuff like that. So
Cool.
it's another really good resource for kind of automation.
That's pretty cool. That's called, yeah, my wife is also a software engineer. She does more than I do. I'm jealous. Continuous integration. Somebody else help me here, maybe, but
We
it's,
use that for actually
yeah.
for exactly that purpose.
Oh.
Building, basically
Automated builds.
automation together with Jenkins and the whole.
That's the one I was thinking about, Jenkins. Also, Hudson? Something like that? Are they similar too? Not Hudson Hawk, that's something different. Yeah, something pops in my head.
Yeah, there is someone posted to the Twitter feed yesterday, Project Boar will do binary related stuff that you can push. I looked through it briefly last night and this morning, but like I said, we'll include all this stuff in our slide notes and stuff as well. So anyone else have questions or comments?
We get to learn stuff too.
Yes, sir.
Speaking of managing your monthly config with Git, people probably have sort of different catalogs for development, testing, and production methodology. But that's sort of analogous to Git branch.
Yes.
But
Yeah.
because you're only on one branch at a time in Git, there's a process. Is there any way to leverage Git branches and have those sort of new branches sort of presented in multi plans? So it's more to make Git branches and more, more
Yeah, that's one way. The other way you could do is even though I said you don't want to make multiple folders, you always have the Git repos always in one folder. So version, I kept checking out multiple versions and multiple folders. This is where you may want to, you can check out multiple copies of your Git repos. So you could have one checkout of the master branch in one folder, and then you can make a new folder and say, oh, I want to clone the repository, but I want to clone this branch. Here's another folder. So you could have that, and then you could symlink those to wherever you want them to go. So that's probably the easy way. Kind of separates your folders. And you always know folder B is always branch B, folder A is always branch master or A or whatever like that. So that might be the way to go for that. That's great. Good question.
Anyone else have anything want to add?
Yeah.
No? Cool. Thank you, and feel free to contact us if you guys do have any questions, either about our slides or anything, even Git related. Let us know.
Definitely.
So thank you.
For those reconvening for the lab, we look forward to.
Yeah, we'll take a 15-minute break and then we'll be back. Thank you.